are literally shaping the planet.
Purpose is the only pathway to a regenerative future.
We have a choice to stay with the status quo or to change.
What is the point of trying to be just resilient when we can actually innovate?
My name is Benjamin Welle. I'm the director of Energy Lab at Perkins and Will, which is one of several labs under the research program directed by Dr. John Haymaker. And, it's always rough to go towards the end of the day of a second day conference, much less after the great, keynote speaker and the great talk that Paul gave. But I was very happy to hear him touch upon HVAC and the importance of airflow. And it's a topic near and dear to my heart that I'm going to do my best to build upon in my presentation by talking about what I like to call the JAWS effect and how it will accelerate investment and adoption in technology in the AEC industry. So to set the tone, got my gear here. So how many people recognize this after 45 years? How many of you have had a visceral reaction to it? How many of you have had some degree of fear and being in the ocean because of it? Has it impacted your behavior before, while considering or actually being in the ocean? Fear is a very powerful emotion. What is the JAWS effect? Well, when you decompose it, the fear of being attacked by a shark is due to 1, the person is in a medium, water, they have no control over. 2, there is a perception of an unseen threat. 3, that threat could cause significant harm or death. Does that sound familiar? Now, fear is often irrational. The probability of a person being attacked by a shark in the water is 1 in 3.7 million, yet we know this fear is very real and very powerful, despite the odds. When people start returning to the workplace, they will be in a medium, air, they have no control over. There's a perception of an unseen threat, and that threat could cause significant harm or death, not just to them, but their friends or family. Now, the probability of being infected with COVID is a complex and highly variable number based on location, time, choices of behavior, politics even, to predict. But a recent study cited that 2 in 3 people know someone that has been infected with COVID. So it's pretty safe to say that the probability of infection per the number of human contacts is orders of magnitude higher than being attacked by a shark. The fear aligns really well with the reality. While the movie Jaws gave people a visual to associate with the fear, there already exists a fear of COVID in the workplace with very few visuals. Imagine once people start to see things like this. You're like, oh, that's how we work in our office. They'll pause, and they now have a visual to associate with that fear. And what about when studies and visualizations like this make their way to mainstream media, and they realize that the 6-foot distancing standard is over 100 years old and assumes static air? If you even have a gentle breeze, that safe distance goes anywhere from 10 to 20 feet or more. What is a gentle breeze? Well, according to a paper just published by the peer-reviewed scientific journal, Physics of Fluids, saliva droplets released by a cough can travel 18 feet in 5 seconds in a breeze of less than 2.5 miles per hour. Now, it just so happens, a common rule of thumb for conventional HVAC supply air speeds is to induce what's called the Coanda effect, or turbulent flow, for the intent of well mixing air in the space. And that is 150 feet per minute, or 1.7 miles per hour. We work in breezy buildings, and they are never well mixed. Even scarier, this simulation done by researchers in Finland shows that even with barriers between 2 people in a grocery store and with typical ventilation airflows, it took a few minutes for the aerosols to disperse. Our understanding of viral aerosol dispersion is not very good. So when people have such visuals to put with their existing fear, it's exacerbated. How will this fear impact their behavior? And remember, this fear is compounded by potentially a fear of losing their job and or the fear of long-term economic repercussions of, say, a volatile market on their retirement investments. How does fear impact worker productivity? Well, we know for certain it'll likely decrease it substantially, but by how much? While the pandemic is often referred to as unprecedented, that's only in modern times, not in US history. The 1918 Spanish flu pandemic did provide some data, which was very difficult to find, on the effect of this type of fear on productivity. Some of the research had estimates ranging from 20 to 40% in decreased worker productivity. And of course, it's not a apples to apples comparison, and the impact of our highly interconnected world today is totally unknown. But I think it's safe to say the number will be a game changer. How long will this last? Well, the productivity reductions could last well after the pandemic is quote unquote over, which is also debatable state of the pandemic. The estimates I just listed were averaged over the active pandemic period and 2 to 3 years after. Now, given that salaries constitute 13 times more than the cost to design and construct a building over a 50-year life cycle, even a small fraction of the above estimates will fundamentally change the economics of our industry as we are accustomed to today. Of course, the magnitude of that effect depends on how much remote working becomes the new norm, but remote working has its own productivity concerns. We know we're going to have a fundamental paradigm shift in the importance of HVAC design. It's about to get a lot of love. Poor HVAC design previously meant at worst discomfort and high energy costs, and now it could have life or death consequences. You're going to, most conventional overhead systems, like Paul was touching upon, are based on pushing large volumes of air at high speed to quote unquote well mix the air in the room, which it rarely does. And we want the exact opposite right now. So you're going to see a fundamental shift to low airflow systems, laminar flow, easier to control, with vertical air movement such as displacement ventilation, underfloor air distribution, and radiant systems that offer personal comfort and ventilation control. Previous cost premiums preventing their widespread adoption will be irrelevant now to owners or developers. These systems will improve actual and perceived safety for workers. These systems can also allow for higher outdoor air levels without as severe an energy penalty as increasing outdoor air will for existing buildings and conventional systems. There are a variety of reports out there already attributing localized outbreaks within buildings to airflow patterns. This type of data will become more commonplace, more compelling, and potentially lead to changes in building codes, sustainable building rating systems, possibly even regulations in buildings that say, if you have a less than ideal HVAC system, you're only allowed a certain occupant density. The more localized systems, a higher occupant density. This would only increase the value proposition of these safer systems. Not only improved worker productivity, but more workers in your office in a given space, and thus higher returns. What people want to see is something like this. If I saw this coming into the workplace, I'd feel pretty good about safety. This is an example of kind of how these displacement ventilation or UFAD systems work. However, the viability of these systems is much more tightly coupled to building envelope design than conventional ones, increasing collaboration requirements between architects and engineers. Some examples. These types of systems are not effective with high perimeter to interior ratios, i.e. massing, or buildings with many spaces, i.e. space layout, which have highly variable loads, i.e. fenestration design. They're good for open plans, not small spaces. Underfloor plenums could reduce or increase building height, costs, and eliminating supply plenums will impact drop ceilings and thus lighting design. Most architects are not accustomed to designing with these types of considerations in mind. If they get it wrong, it will result in a massive rework costs and schedule delays, or you end up putting in a hodgepodge of HVAC systems to account for those deficiencies. This increases cost, complexity, and the likelihood of something going wrong during operation, which Paul noted is already a mess right now. These more stringent collaboration requirements on how architects and engineers fundamentally work together will be exacerbated by the collaboration changes inherent to working remotely, should it remain that way. Well, we know for sure that building simulation, such as CFD, energy daylighting, will happen more often and earlier in the design process. CFD software companies and consulting firms know this very well. You'd be hard-pressed to find one that does not have some reference to COVID with a simulation video below it on its landing page of their website. Architecture firms, such as Perkins and Will, rely on consultants to either one, engage them earlier and more often, increasing costs, or two, mitigate costs by bringing simulation capabilities in-house and investing in knowledge management and reuse, which will require some degree of AI to make sure that it's effectively implemented and used, because they will be very unfamiliar with it during the initial stages. Lifecycle costing will start to include worker productivity benefits, and value engineering, as we know it, will be far more constrained with greater consequences given these new considerations. So some of you may have heard about the catchphrase pandemic of lawsuits. So already we've seen several hundred coronavirus-related lawsuits ranging from wrongful death as a result of unsafe work conditions to wrongful termination for discriminatory reasons. And this is happening when people had little time to prepare, no precedent, and let's just say a severe lack of support and guidance at the federal level. So what happens when pandemic 2.0 hits? Experts warn that population growth, the increased interconnectedness of the world, deforestation, increased human-animal interactions all point to a very high probability that another pandemic will occur within the lifespan of a building. So owners and developers will demand performance accountability for project teams to mitigate litigious risks as well as productivity risks, given the massive financial consequences of not doing so. And at that point, during 2.0, precedents will not work in their favor, meaning the industry will have had time to learn from the current one and prepare appropriately. Plaintiffs are far more likely to win. Performance-based contracting will be the mechanism for accountability. And we all know the gap between as designed and as operates is already currently massive. Owners will want to ensure that the premium they're paying for a safe, healthy, high-performance work environment is delivering by making, for example, 10% of fees, a sliding scale based on how close teams meet their target, as well as clear minimum requirements for system performance. Again, these systems having less precedent in the US, more so in Europe. This will have profound impacts based on the makeup of project teams, the project delivery process used if goals are not met, and you're a more traditional, purely architectural firm like Perkins and Will, in a design, bid, build, delivery process, the finger pointing will start. Architect to engineer, engineer to contractor, vice versa. And if these firms start losing jobs to tech-based firms that enter the industry that are better able to deliver on performance, that loss of market share will force dramatic and costly technological consequences and adoption. Integrated AE firms and design build projects will weather the storm more effectively, but still struggle. What are the impacts on energy and sustainability goals? Well, current HVAC safety recommendations by ASHRAE, such as greater outdoor air for dilution, improved filters, night flushing, pre and post occupancy, will increase energy consumption considerably for the existing building stock for quite a long time. So as global climate change mitigation only cares about absolute reductions in energy use, energy efficiency targets, initiatives, energy codes for new construction, major renovation must take this unavoidable reality into account for future requirements to offset it. And things like energy, daylighting, thermal comfort, healthy building goals, I believe will accelerate, but the major driver will be the economics of worker productivity and litigation risk mitigation. How about the impacts on investment and adoption of technology? Well, there will be massive improvements, the requirement that there be massive improvements in collaboration coordination, a shift to unfamiliar building systems, changing roles and scope, and simulation more often, earlier, will require investment in new technologies, whether through VCs or internally by AEC firms. This will be owner or developer driven based on performance-based contracting, and it will force the investments to be made and the adoption of these technologies. What technologies? Well, technology specific to the topic I'm talking about, design computation tools, data analytics, big data, AI, and what I like to call lifecycle platforms to streamline the other technologies and address the collaboration coordination requirement. So I'd define lifecycle platforms as, for example, tech stacks that integrate multiple related analyses, energy, daylighting, airflow, solar, water, etc., due to the synergies in their analytical model requirements and the related physics to enable true multidisciplinary analysis without having to depend on disparate tools, people, and firms as they do now. They enable efficient collaboration, coordination, and use across all relevant design roles and phases by intelligently changing modes based upon the specific need, and is able to seamlessly round-trip information to more detailed analysis tools if desired. This includes client engagement, Think of it as a single product that serves as many products. VCs recognize opportunity. These challenges and needs are long-term, needed immediately, and highly profitable for early investors. Investors understand the AEC industry's technological lag behind other industries. Its notorious stubbornness and slow pace to change is no secret, and the rapid technological changes that will be required to maintain competitiveness with the new norm makes the industry ripe for disruption, really across the board. In 2020, there was approximately $1 billion of investment over 54 deals, signaling that their willingness to invest despite an uncertain and volatile market and economy. Now, typically, the domain of building simulation does not have the margins to achieve a 10x return in 5 years that VCs look for. However, if you take the lifecycle platform approach, like I proposed, then you're able to tap into the most significant sector for financially impactful technological applications, i.e. project collaboration and coordination. This table right here, which is from Built World's market research report, which was done pre-COVID, shows us this is the case across the board, from architect to engineer to contractor. I'm sure the numbers are even more compelling post-COVID. That would allow such simulation tech stacks to potentially meet the VC metric for investment attractiveness. So next, I'll talk about one solution that we've been working on over the past 4 years at Perkins and Will that addresses a number of these concerns, but not in a holistic manner. It's called SPEED, the Simulation Platform for Energy Efficient Design. It's only in V1.0, but it does embody many of the technologies and capabilities I described for a lifecycle platform. Lifecycle platform is required to address the Jaws effect. It serves as an example of a private firm taking the initiative to invest and adopt a technology to fill a gap they know must be filled because they understand the dramatic change on the horizon. A technology that can be easily integrated, a variety of design workflows, and applied effectively within the cultural ecosystem of the firm. While the investment costs do seem high to management, particularly since the investment is in a domain the firm has little experience with, i.e. software development, the firm does understand that the costs of business as usual are orders of magnitude higher, and thus the return on investment is beyond compelling. Such a technology also serves as an example of the type of tech stack investors should be considering. It integrates multiple analysis types, though we would like more, has a fair amount of AI and a high degree of automation underneath it, and it does have a few examples of how such a platform could dynamically change based upon the needs of the user. However, it was intended for a specific audience and design phase, architects with little experience in energy modeling for early design. Thus, it doesn't serve to be used by all levels of experience across all design phases, like is needed to meet the challenges I discussed earlier. However, the architecture was designed so it potentially could, such as using Energy Plus and Radiance for energy and daylighting, respectively. Those are the same engines behind most of the commercial applications used by mechanical engineers and energy modelers, setting up the ability to either be used directly by the expert by exposing greater functionality in the GUI, or having the information extracted, used in their application of choice, and re-uploaded to the parent platform. This would basically allow for a singular data lifecycle flow that is preserved throughout the project, which we have in no way, shape, or form right now. Data and assumptions made by one party may be easily communicated and modified and passed to another user and passed back and forth upstream and downstream as needed. This is where the highest value added lies in terms of project collaboration and coordination. What you see here is kind of the core of the platform, the parametric study, which allows designers to run thousands of design options in a matter of hours in parallel in the cloud. The results are returned, post-processed, and visualized. Now, generating all this data is only as useful as the ability of the person looking at it to understand what it's telling you, and that's a very challenging thing. Visualizing large design spaces and interpreting them is difficult. We use the most common types of charts and graphs, but there should be no need to try to train designers how to interpret them. There should be a design question-driven solution that automatically post-processes the raw data, and say an avatar of choice by the designer pops up and gives the direct answer to the design question with some range of uncertainty. The visualizations should be complementary. If the I as an energy modeler can look at some chart or graph and interpret what it's telling me given a design question, we can put that knowledge into code much faster than we can train users not accustomed to such visualizations and how to interpret them. That's high on our wish list. So there's a wide range of value propositions of the platform being listed now, but I'll jump to the last one. When considering what a litigious environment might look like between a building owner and a building occupant, or a building owner and a project team under a performance-based contract not meeting the goals or minimum requirements, the party that has a lifecycle platform such as this one, that has well-documented assumptions, version management, process-related data stored and retrievable on demand to present to the courts, will be far better positioned to win that suit than firms that can't generate this information, which is pretty much every other firm right now, vastly increasing its value proposition. So with that, I will take questions.